crosses borders between these different ecosystems, and very timely, I think, now to have this plenary session focused on fire and fire history and the consequences that we're reaping from changes that have occurred over a long period of time, changes caused by humans as well as natural factors. So I'm going to give an overview, start with some history, and Dale gave a great preamble, if you will, there about the value of history, importance of using history and thinking about the past, using it as perspective to understand the present, and hopefully using some of that understanding to prepare for the future, even maybe predict some aspects of the future. Well, as you can see also from my title, it has some ominous undertones here, dust bowls and firestorms, and again, somewhat appropriate here in Oklahoma, in the heart of the Dust Bowl, to talk a little bit about that in the context of the changes that we're seeing. I'm sure many of you are well aware of the history here, some of the elements that contributed to the Great Dust Bowl of the 1930s, and you probably also may have watched Ken Burns' recent documentary, excellent documentary on the Dust Bowl and the people and the ecological and social circumstances and the climatic circumstances of that great event. And I recommend to you this book by Tim Egan, who was in the documentary film as well, The Worst Hard Time. A number of amazing stories in there to read, how people lived through the event, and many people died too, of course. Phenomenal, 49 dust storms in a 90-day period or so. Very apocalyptic kind of a landscape and circumstances, people seeing these massive clouds of dust bearing down upon them. And the story, in some ways an oversimplified story, but still many elements of truth in it, is that this happened as a consequence of humans changing the landscape, increasing the vulnerability of the landscape to climate variability. The prairies had withstood many previous droughts and had withstood them, and the ecosystems had survived, and the soil did not blow away. Well, the combination of human development, many thousands of farmers moving to West Texas, Oklahoma, eastern New Mexico, eastern Colorado, brought here by the promise of open lands and productive, fertile landscapes. The rain will follow the plow mythology. And indeed, it was good times, and the economics of it and the climatic conditions favored the development of vast farming areas and the turning over of the ancient prairie sod. And then economic and social factors came to play: the end of the First World War, the drop in the markets, the Great Depression, and so much of this landscape went fallow. And then the drought hit, the extreme drying condition, the hot temperatures sucking the moisture out of the soil, parched landscape, and then the wind, extraordinary winds coming across the plains, picking up the dust and carrying it away, and carrying the soil away, and carrying away many of the people as well. So this is a story that has truth in it, and it's a story of increasing vulnerability where if we change the landscape in certain ways, we can make it more vulnerable to natural variability. Climate variability is not all driven by humans. In recent decades, mostly is, but natural climate variability can impact, especially when we have humans changing the situation. This whole story comes home to me pretty personally. My parents, Fred and Grace Swetnam, grew up in Trinidad, Colorado, right there on the Front Range, kind of on the rim of the Dust Bowl, if you will. And my dad, you see him here, standing on the running board there, that Model T, that little boy right there is my dad, about 1930. And my grandfather Zeph inside the cab there, and my uncle Morton and my great uncle Freddie. This is probably about 1930. And so through the 30s, the 35, 30s, 36, 37, some of the great dust clouds came across Trinidad. And I remember the story my dad told, particularly about that old Model T. He recalled that they had rolled up the windows tight and battened down the hatches in the house. This dust storm came through, black as night in the middle of the day. Came out afterwards, opened the door on the Model T, and there was an inch of very fine dust inside that closed tight truck. The dust got into everything and everywhere. It had a big impact on him, I could tell, when he told me the story of that event. And so it impressed him. And later on, incidentally, he was in the First World War and GI Bill, Colorado State University, and range management and forestry, and became a district ranger with the U.S. Forest Service. There he is down in the lower right, talking to a sheep man there in northern New Mexico. And he was always impressed on me the fact that we don't understand all of the changes that occur on the landscape, and that we must be humble, practice humility, because we will be surprised. Even though we think we can manage, we often can't, especially when things are changing and we bring about changes. The parallel and the analogy with fire, of course, is there with regards to the vulnerabilities. And we have extinguished fires for more than a century in places where fire was very natural and frequent in some cases. And by putting fires out, we've changed the landscape and increased the vulnerability. It's quite interesting to see this case of Ehlers Koch, who was one of the original rangers and was on the Bitterroot National Forest and was a survivor of the 1910 fires. He was in those fires, fought them, and years later he had a turn of mind. He changed his mind about the wisdom of fighting fires, and he wrote an essay in the Journal of Forestry, which I think this is for the quote at the top there, is where he was questioning the wisdom of putting fires out and asking, really, have we accomplished anything? He was doing this in the context of some very large fire events that had just been occurring in the 1930s in some areas in the West, and he asked this question, and he makes the connection, see there, with like plowing up the good buffalo grass sod in the dry prairies. He made that connection himself. I'd recommend to you as well these other two books here, Tim Egan, The Big Burn on 1910, the Forest Service, and Steve Pine's fine book as well on the history of the 1910 fires and studying this. So again, the point is about vulnerabilities and changes in the past. So this is a lesson of history that we should think about in terms of what changes we bring to the landscape and what are the consequences. Another quote here from Mark Twain on the right: history never repeats, but it does tend to rhyme. So, we don't use the past to try to exactly predict what's going to happen. We know that all events are different through time, ecosystems and climate is very complex, but we can still learn about the nature of the dynamics. And in this case, we can also learn about what changes are occurring and whether we're in extraordinary conditions. If you look at this graph of March, April, May temperatures over the whole coterminous United States, you can see very clearly that we're in this trend of warming, extraordinary warming conditions in the springtime temperatures, especially. This is really important for fire, especially in upper elevation landscapes, some middle and lower elevations as well. If the snowpack comes off early, the fuel's dry, and then as you come into the long, hot, dry summer, this early spring conditions can be really critical. Another interesting comparison here, rhyme, if you will, of history. This last year, 2012, broke the previous record for springtime temperatures, the previous one being 1910. A paper with my colleague Henry Diaz in press that we compare the climatology of 1910 and the spring, winter before and coming through the summer with 2012. And there's a number of very interesting parallels there in both the warming of temperatures and hot summers and wind. A very important factor, which I'm going to come back to here in the talk, is the importance of the jet stream and pressure patterns and winds driving a lot of our major fire events. And it was a case in the last few years. Well, we're a few days past Groundhog Day, so I thought I would put this in part also reflecting on the apocalyptic nature of my talk here. I'm not trying to argue that we're all going to die, but indeed some big changes are coming at us right now. And interesting to note the earlier spring comment here in this particular cartoon. We see other echoes of the past. dust storms. Some major dust clouds have rolled into Phoenix in recent years. The so-called haboob is a term from, I believe, northern Africa, Arabic term for giant dust storms sweeping across landscapes caused by parching of the landscape and wind. And various kinds of meteorological conditions can create these kinds of events. And just a few weeks ago, this red cloud coming over part of Australia there. And again, these kinds of things are unusual. They have occurred in the past, and but they're tied in with this extreme conditions, instability of the atmosphere, tied in with drought conditions, and it's with fire too. Now, the last several years, we're in the great drought of the 2000s. The western U.S. and the southern Great Plains experienced the greatest droughts of the last 100 years or so, 1930s, 1950s, and now the 2000s drought. Time will tell whether this drought eclipses these previous droughts in terms of magnitude. In some cases it already has in particular places and particular meteorological records. Temperature records have been broken for some months and some seasons in a number of places in dry conditions, and we see extreme behaviors. So this is another theme of my talk, if you will, is that we should expect to see extraordinary fire behaviors because there are nonlinearities in the responses. That is, as temperatures increase and fuels dry out and fuels are abundant, we shouldn't just expect more and more fire, but also some different kinds of fire behaviors. There's a fire whirl there. Vortices are a characteristic of instability of the atmosphere. Vortex, spinning tornado-like fire behaviors at varying scales, from local on the fire line all the way up to a whole column of smoke plume coming off of a raging ground fire. Well, this is 2012. The drought shifted a bit up into the southern Rockies. Extreme drought, especially in the Colorado Front Ranges, and many fires in that area. And then this is the outlook for the next 3 months. This was released a few weeks ago, January 17th, and so the picture's not pretty. This is the long-range 3-month outlook of what's coming. So we have we're in a drought. We've been in a drought in various parts of the country for quite a while now, and it's likely to continue. So some perspective, if I can get it to change. There's a bit longer perspective on matters, and naturally I want to bring in some of the tree ring work here to talk about the longer time scales that we're able to look at and the value of looking over long periods of time, as you can pick up rarer events. You know, if you have a shorter record, you're unlikely to see rare events. Rare events by their nature don't occur very often. Longer period of time, you tend to see more extreme events as well. Well, we had the good fortune to work in giant sequoia groves for about a decade in the 1990s, and these are marvelous trees for studying fire history. They have fire scars, many of the oldest ones. This is the grizzly giant in Yosemite National Park, and we were able to sample 5 different sequoia groves, taking big sections from dead trees with chainsaws, stumps, and logs. You'll be happy to know we didn't put any big chainsaws into living sequoias, but we obtained a lot of wood and brought it back to our laboratories and developed 3,000-year-long fire histories from giant sequoias. And they have fire scars, abundant fire scars embedded right in the stem. We could get, in some cases, that big section on the previous slide had more than 80 different fire dates on it over 2,000 years. Make a long story short, because I'm in the interest of time here, we learned a number of things from this study. One of them is that the fire frequencies went up and down through time, through the decades and through the centuries, and the maximum period of fire frequency was in the so-called medieval warm period, medieval drought period, from about 900 AD to 1300 AD, an exceptionally dry period in the western US that we know from tree ring studies. That was the maximum fire frequency. In general, there's a close coupling between fire frequency, fire events, fire frequencies, and climate. No big surprise there. But we have a number of things from these studies besides just the the obvious that climate and fire are linked. We learn a lot more about the details, the specific timing and lagging patterns and all sorts of other things. One of the clearest patterns that we see across the western U.S. is that in these frequent fire regime types, surface fire regime types, pine-dominated forests, mixed conifer forests, savannas, grassland areas, frequent fires, and that those fires tended to cease right around the turn of the century. So this complicated graph, what you should take from it mainly is the lack of fire in that last period there. After about 1900, there are very few fires recorded. The yellow and red tick marks are fire dates on trees in stands, in forest stands. So the white lines, the horizontal white lines, are individual forest stands all over the southwestern United States. And the yellow and red tick marks are the fire dates. And the time scale goes back to 1600. So you see all these fires here, many, many fires for hundreds of years, and then the lack of fire in the 20th century. This disruption of frequent surface fire regimes, the timing of that very typically was when large numbers of livestock were introduced on these landscapes, sheep, cows, and usually a decade or maybe even 20 or 30 years before the Forest Service and BLM and Park Service and government agencies began putting fires out. So livestock, intensive livestock grazing was the initial disruption. Interestingly, we see continued fires in some places with livestock grazing. It's not, not any livestock grazing will reduce fire activity, but just the really heaviest with larger sheep in particular. Well, here's one of the things that we learned from these tree ring studies about climate variability at the big scale is that we can see these patterns and spatial patterns sorting out over the scale of the western United States. So on the left, all these orange pins are where there are tree ring-based fire histories, fire chronologies from fire-scarred trees. And there's a lot of them now, more than 800 sites. And we just recently pulled this together into a big network. And on the right is a map showing the drought history with the sites that recorded fire in 1748. So the drought history that's in the map on the right is based upon a completely different set of tree ring chronologies from ring width measurements. So we have hundreds of tree ring chronologies, measured ring patterns, the ring width patterns from drought-sensitive conifers over the western U.S., and that has been carefully calibrated as a drought index going back hundreds of years, and then we produce maps showing the estimated drought magnitude over the region. So the colors there, the brown colors are droughtier conditions, and the green are the wetter conditions estimated from the tree ring width chronologies, and the red dots are the dates recorded by fire-scarred trees in the fire scar chronology. So the different chronologies comparing here, and you can see it works pretty well. We see these kinds of years like 1748, massive fire year, especially the Southwest, with many, many different mountain ranges on fire in that year. Extreme drought year in the southwestern U.S. The interesting thing, though, spatially, is that we see these other patterns, like this one. This is a classic dipole-like pattern where the Pacific Northwest and the Southwest are out of phase with each other. So the examples here, 1783 on the left is the very dry in the Pacific Northwest, droughty conditions as indicated from the tree ring width reconstructions of drought, and many fires recorded up there on the fire-scarred trees, and almost none recorded in the Southwest. And then on the right, the reverse pattern. It's wet in the Northwest and dry in the Southwest. So this is a pattern. We see this in the modern climatology. You can see this clipping, this dipole pattern. The climatologists have identified this in precipitation patterns, and we see it reflected in the modern fire activity records as well. And what is this? This dipole pattern, it typically has in relationship to the El Nino, not always, but commonly it's connected with the El Nino pattern. And the point of this is the importance of circulation, of atmospheric circulation on climate. And this is all relatively new stuff. The last 20, 30 years, really we've learned a lot more about El Nino and its relationships to climate, and more about its relationships to fire. In essence, when you have an El Nino event, the jet stream is strengthened, the southern jet stream is strengthened and it brings moisture across the southern tier of states in the wintertime especially. And the northern part of the jet stream is shifted north, so the ordinary precipitation you get in the Pacific Northwest is shifted northward, and it gets dry in the Pacific Northwest during an El Nino. And the flip happens generally during La Nina conditions, the reverse pattern of El Nino. So this has been very useful for fire climatology, the development of this whole field of fire climatology, being able to look at long-term patterns of season to season, even year to year, and using these in a forecasting mode. And so there is some implementation of this knowledge of what is the state of the El Nino in thinking about upcoming fire seasons. But this also has importance and relevance in thinking about the jet in general, which I'm going to come around to here in a moment. More aspects of the jet stream. Well, I referred to this earlier, this kind of nonlinear effect. You know, as climate varies, as it changes, we shouldn't necessarily expect that fire is going to respond in a linear way. That is, for every increment of temperature increase or every increment of increased droughtiness, that fires are just going to ramp up at the same rate. In fact, they tends to ramp up at a nonlinear rate. So this is a comparison here on the left of the number of large fires in relationship to the incremental increase of temperature over the last 30 years that we published, Tony Westerling and a group of us published in 2006. And this shouldn't surprise us. Fire is, in fact, a nonlinear process. You know, the spreading of fire is nonlinear. You get larger and larger areas spread faster and faster. But there are also nonlinearities in the climate system itself. As the atmosphere gets warmer, as the air gets warmer, it has greater power to evaporate and suck the moisture out of the fuels. Okay, so there's a number of nonlinear kind of actions going on here that create this sort of very rapid response. So we're talking here about tipping points where suddenly we see the behavior acting kind of in a predictable, general linear way, and then suddenly there's a shift, a switch, a very sudden to different kind of behaviors. And the fuels. Okay, so on top of all of this, we know that the fuels have changed, forests have changed, and this, you know, different landscapes, different ecosystem types, different responses. It's not the case everywhere that forest fuels have increased. But clearly they have in the pine-dominated forest ecosystems across the West. Many of the savannas, grasslands have had woodification, woody species spreading into them. This is just an example. You can see many of these kinds of examples, aerial photography, repeat photography examples, where formerly open forests, these are the whiter colors here, are lighter because those are savannas on slopes, and open pine forests shifting to closed pine forests. And so this is a common story in the West. And again, I don't mean to say that it's all landscapes of the West are like this by any means, but our pine-dominated landscapes especially. And those of you working in rangelands, many examples around the West of encroachment of piñons or junipers into rangeland. And this is complicated. It's not always fire suppression. It's not always livestock grazing. In some cases, it's moving. These species are actually moving across the landscape over long periods of time, maybe centuries. Piñon pine, for example, has been moving northward throughout the Holocene across the western United States. So these are, there's long-term movements and short-term movements and different causes. But in any case, the fuels themselves are leading to some massive changes combined with the warming temperatures. So we're seeing extraordinary behaviors. I just wanted to point out a couple of the things that are happening in some of our pine forests in the Southwest, and also talk a bit about some of these exceptional vortex fire behaviors that are showing up in some of these, because I think it's relevant for a lot of other landscapes as well. This is a photograph of the Las Conchas fire near Los Alamos in 2011. I didn't put in the video here because sometimes it doesn't seem to work on PowerPoint, but you can find it. If you want to see this, go to the YouTube and search on this Zeiler, Z-E-I-L-E-R, and Las Conchas, and you'll find this video of this vortex fire running across the Pajarito Plateau near Los Alamos. It burned 40,000 acres in about 6 hours, and it was like a tornado. It's a spinning vortex, and that's about 2 miles across. The base of that smoke column is about 2 miles across, and there's burning gases several thousand feet up into the atmosphere. So this is a tornado of fire moving across the landscape, driven by very dry conditions, exceptional wind conditions, and fuels. The fuels here, what's going on in a lot of our forests are converting. They're converting to shrublands and grasslands because of multiple fires. So now we're entering an era where you're getting reburning of previously burned landscapes at high severity. This is a picture of this landscape near Los Alamos. I think this was the Cerro Grande burn that came back as gamble oak. Those reddish leaves there in the fall are gamble, these clonal shrubs coming back into a former forest. The dead trees are falling down into the shrubs, and then in a dry, hot condition, this burns incredibly hot. So the second burn is magnifying the effect in extraordinary ways. The Las Conchas fire had this vortex fire in the afternoon, and at night there were plume-dominated behaviors and a firestorm out there. And the fire blew all the way down from the montane elevations all the way down to the pinon juniper woodlands, almost to the Rio Grande. And it was burning through PJ woodlands that had virtually no fuels on the ground, very widely spaced trees. It just a firestorm right down through and killing 400, 500-year-old alligator junipers on this landscape. Well, I've never seen anything like that. And I don't know of any evidence of an event like that at any time in the last several thousand years. You'd see old dead burned snags in that pinon juniper for a long time, and you don't see that in the middle of Rio Grande. This is an exceptional kind of view occurring on these landscapes. Big blowout canopy holes driven by wind. This is the Wallow fire. And you can see in the burn severity map, these reddish features, very linear. These were wind-driven fire events when it really blew out big canopy holes, up to 10 or even 20,000 acre canopy holes. This is 8 miles or so in length right here. And you can go on Google Earth, and I challenge you to find any living trees in there. So these are big, big canopy holes that are very likely now converted to something else. They're not going to come back to forest anytime soon. These forests aren't adapted. They're heavy seed and no long-range dispersal except for birds. And the shrubs can come in. So here's where, this is actually, I think, a really critical point for range managers, is to think about what we can do now. I'm not convinced that we can alter this situation through restoration efforts effectively over most of the landscape. And so now we need to start thinking about how to direct the succession on these places after the fact. And we might decide in places like this that we would prefer a grassland here to a shrubland. But in order to do that, you're going to have to get in there and treat quickly. You can't allow the clonal shrubs to dominate the landscape, because they will, and they are. And that'll perpetuate a shrub landscape rather than a grassland landscape. Well, this last couple of things about the winds and vortex behaviors and big circulation. This was a picture of that Las Conchas fire that first afternoon, and it struck me the linear shape of it. You can see on satellite images the smoke plume was coming all the way up to Nebraska, just kind of in a long tendril, spiraling tendril, all the way up across the plains. And what this is showing is the wind shear effect, higher wind speeds as you move off the ground. And you can see this again and again across the Southwest. You can see it in more recent fires this past summer in Colorado. Some of the big blow-up fires there on single days, the plume is wind-driven. It's not a vertical collapsing plume. It's a wind-driven plume, and the wind events are really, really important. And when I saw that, I was reminded of this old paper I'd read years ago by Vince Schaefer from the 50s. Vince Schaefer was a climatologist and working with the Missoula Fire Lab and Jack Dietrich, and they just happened to be on the Mogollon Rim the day this fire blew up in 1956, the Dudley Lake fire, and they watched it go. It burned about 10,000 acres in an afternoon, and that was a big fire back in the 1950s, and it was a vortex fire. And there's even a video, which I haven't seen yet, that shows this thing spinning across the plateau there. And Schaefer connected this with the jet stream. He said this may have been related to a low-level jet and the position of the jet stream coming on. And that brought to mind some discussions among climatologists now about the behaviors of the jet in the context of climate change. And I came across this old Time magazine, 1957, and on the cover there is Carl Gustav Rosby, who's kind of one of the fathers of modern climatology. He's the guy that really described the physics of Rossby waves and the circumpolar movement of these rivers of air moving around the pole as a consequence of the temperature difference from the pole to the equator. And the rotation of the Earth and the Coriolis effect creates this spinning winds that move from west to east around the poles. And in this interesting, this just as an aside, this Time magazine article had some photographs in it about fire. They were discussing it even back then, talking about the jet stream and fire, and connecting it to Jack Schaefer, or Schaefer's work and Jack Dietrich's work. But the point of this has to do with the changes that we're seeing now. As the polar ice caps are melting, and they're melting extremely and rapidly, there's a less of a gradient from the pole to the equator. So the jet stream is driven in part by this gradient. The cold northern pole and the warm equator creates a steep gradient, and with the greater gradient you get fast wind, fast jet stream that tends to move linearly around in a zonal manner like this on the left. But if you decrease the gradient, if you melt the ice, then the jet stream slows down. And when you slow down the jet stream, it starts to meander. So again, it's kind of when you have a steep gradient of temperature, the river of air moves straight down and fast. It moves in a zonal way, but if you level it out, the river starts to meander. And so you start to get these meanders. What that is, then you get ridges and troughs. And because the jet is slower, those troughs and ridges move from west to east slower. So what you get then are these persistent ridges that can sit over like West Texas and eastern New Mexico and Oklahoma for weeks at a time. And if it's at the wrong time, in the spring and summer, everything dries out. So there's long, persistent ridges, drying everything out for weeks on end. And then, finally, the trough starts coming in from the west, and when that trough comes across, all hell breaks loose. The winds kick in. You get wind shear, you get cold air overriding warm air, you get tornadoes, you get tornadic behaviors, you get big blowout fires. Okay, so this is a general pattern. I'm not the one everywhere. It's not the cause of all of our big blow-up fires or wind-driven fires, but I think it is a major one that we're seeing now in many places. Just a quick example, extreme one, was over Russia in 2010, a massive heat wave. This is, if you can pick it out, there's Spain over there in the Mediterranean, and this big heat wave moved north and sat over Moscow for weeks on end, dried out the bogs there. The wet bogs started burning, smoke all over Russia and Moscow. They shut down the airport. Thousands of people died in Moscow. They just don't have very good air conditioning infrastructure there. A lot of older people were dying. Literally thousands of people died during that heat wave. And then there was a giant flooding event in Pakistan, just downstream from that. And so these big wave-like features are recurring. Take a look at Sandy, Hurricane Sandy sometime. You'll see these, it's a combination of position of the jet and air mass movements and collision of air mass movements and creating these instabilities. So the issue here is that this is something to watch out for as fire managers and thinking about the season as we start to set up these extraordinary kinds of wave-like motions. We need to be aware of the extraordinary kinds of responses that we can get. This was the position of the jet just prior to the big Wallow fire in Arizona, and in the interest of time, I didn't put in some results. We've been studying, I have about 50 events like this over the last 30 years in the Southwest, and been looking at the climatology of these 50 wind-driven fires over Arizona and New Mexico in the last 30 years, and very consistently, significantly, these are commonly related to these sinuous positions of the stream. The last thing I'm going to say here, just I'm pointing out a lot of the problems and really not offering any solutions, but I want to say that I believe that there are some solutions there. We really need to engage with this process, and there are ways to mitigate fire risks and reduce fire effects, bad fire effects. This is just a quick anecdotal example of the Wallow fire, where some thinning treatments, reduction of fuels, probably had an effect on reducing fire in the wild down urban interface. And again, I think the value is thinking about what we should be doing on these landscapes now as they convert. If we cannot prevent these wind-driven fires from raging through and changing our ecosystems, what can we do about directing the change after it's occurred? And in some cases, I think we might consider promoting grasslands instead of shrublands, if those are values that we want to promote. And I think maybe it might be valuable for the future to maintain something in a grassland might be more convertible back to forest eventually, whereas if you get an extensive clonal shrubland, it may be much more difficult to get back at any time in the future. Well, I know it's not an easy task, but I commend you all and hope you all will engage in it, and look forward to hearing some questions if you have any. Thank you.
If the lights can be brought up conveniently, let's bring the lights up. We've got about 5 minutes for questions. And you do have to raise